Okay, we're going to use the graph to estimate local maximum and minimum values of the function and the value of x at which each occurs. So we're asked to find an x value and a y value so that the y value is locally a maximum or locally a minimum. So let's think about what that means. So consider the x value of the point right here. Locally, with respect to nearby x values, locally, if you are to the right of this x, then the y values are greater than the y value here at this x. But if you're to the left of this x, then the y values are less than the y value, or less, or actually below this x value. So this is not locally higher or lower than nearby. The y value for that x value is not locally higher or lower. Some y's are higher, some y's are lower. Look over here at this peak. There's a top point at the top here, and locally for x values near this x value, the points on the graph that correspond to the x values near this x value, like close by this x value here, the points on the graph are below this. So this would be called a local maximum. Local maximum. So what is the x value here? The x value here is -2. So the local maximum is -2, and the function value is +2. You can get that from looking at the graph. So that's, but actually, wait a minute, I just realized that this graph is scaled by 5. So actually this is -10 right here, and this is +10 right there. I noticed that because here's the correct answer, -10, +10. So you only have to put those numbers in here. So now let's look at a local, excuse me, there's another local maximum according to this. So let's see where there's another peak. Here's another peak. So this point is higher than the points nearby. So the local maximum will be this x value, which is 5, 10, 15, +15. And the y value, the function value, is +5. So there's your second point that's giving you a local maximum. Notice that they want the smaller x value answer here and the larger x value answer here. So if you put the wrong answer in a blank, it's going to be wrong. So make sure you pay attention to that little detail right there at the end. The smaller x value here is -10, so put that one here. The larger x value is 15, so put that one here. Finally, local minimum, you're going to find a low point. So here's a low point that locally is lower than any other point around it. And what are the x values? Well, the x value here is approximately 0, and the y value looks like about -5. So the final ordered pair is 0, -5. Okay, intervals on which the function is increasing. So now we want intervals, which are x intervals. So intervals on the x-axis where the function is increasing. So let's see if we can find some of that. Here is the function as the x values go from left to right, the function values you can see are actually getting bigger and bigger and bigger because the y coordinates of these points are going up the y-axis. And as you go up the y-axis, it's just like going to the right on the x-axis. Numbers get bigger as you go up. So we say that the function is increasing until it gets to its highest point, and that x value, remember, is -10. So the function is increasing from -infinity for x values from -infinity to -10. So think of the x values of these points. The x values are these x values here. And as long as the x values are up to -10, the function is increasing. Then the function is decreasing. As you can see that the function is going down. It's going down until the x value is here, and that's at 0. So from, I'm sorry, that's x value of, 0. Let me see. Oh, it's decreasing. It's an x value of, it's decreasing to here, x value is 0. They're asking us where it's increasing. So it's increasing here, and it's increasing from 0 up to 5, 10, 15. Right? 0, 15. So the x interval from 0 to 15, and then they want to know where is it decreasing, so it's decreasing everywhere else. It's decreasing from -10, the x value is -10 until 0, so you can see it's decreasing all the way here from x equals -10 at this point until x equals 0 at that point. And then it's decreasing again, starting at x equals 15, it's decreasing because the function values, the function's pointing downward. So that's all the way to, we say, to infinity, so 15 to infinity. Okay, I hope this was helpful.